Microphone check 1 2. It's your boy, the network, back in the building. No, that's not what I wanted. Live stream, episode number 100. Got Lavaris in the building. Got PS in the building. Appreciate y'all for tuning in. We're just gonna do a little discussion on Spanning Tree. Y'all know what it is. It's your boy, the network. Back with another live stream video. We're about 100 episodes deep, man. 100 live streams, man. When I first started this channel, I was doing just little tutorials on, stuff that I learned. I tried to teach it. Try to teach the topics that I learned and stuff like that. So I just started doing these tutorials. And then once you get to, like, I guess a certain amount, you can start doing live streams. And I was just like, I don't think I'm not going to live stream. I just rather do these tutorials and stuff like that. But then one day I just clicked the mic on and the camera, and I just started streaming. I was like, this is fun. This is more fun than the tutorials that I was doing, because I was clipping the videos and it would take a lot of time to edit those. So I've been doing more live streams and stuff like that. But I know I keep telling y'all, I keep promising y'all, I'm gonna go back to doing those tutorials, the CCNA ones that I was doing earlier, and because I've been getting a lot of requests like, hey man, once you finish all of those topics and stuff like that. But I wanted to move on, and I like doing these live streams. So anyway. Shout out to Jeremy Stretch at packetlife.net. If y'all want to copy these are like kind of like cheat sheets for several topics on, computer networking and stuff like that. Specifically, mostly computer networking. And since we were going over Spanning Tree, we're also going to be doing the network simulator, Boson Netsim. Y'all know the good folks at Boson gifted me a promotional copy of all of their products, the Encore labs, CCNA labs, the NRC labs, and also the XSIM exam simulator, where it just asks you questions. I haven't tried that one yet, but y'all know I've been liking the network simulator and stuff like that, because it gives us objectives and they ask you basic questions about certain whatever topic it is, and then you got to go in there and configure it, run show commands, and then you get a good feel of how these applications work. So typically I stream Monday through Thursday, 8 p.m. Eastern Standard Time. But anyways, if you want to copy these like cheat sheets, they got a whole bunch of cheat sheets. There's stuff on VLANs. Like here's another one for VLANs right here. Since we've been doing a lot of VLAN stuff, we'll do a review on that. Again, we're going to do a lot of stuff on Spanning Tree, which we have been doing. I just wanted to kind of go over some of it, because I remember last night we was kind of debating on the timers and stuff like that. So I said, let me grab this spreadsheet here, or not spreadsheet, but these cheat sheets that he has, and we'll kind of go over some of that stuff. Remember yesterday we were talking about the default timers, right? Remember we said BPDUs are bridge protocol data units. They're kind of like hello messages, but for Spanning Tree, right? So each device that is participating in Spanning Tree sends out BPDUs to see, is anybody else the root bridge? Who is the root bridge? And keep sending that information. If somebody has a better what's called BPDU or superior BPDU, then they kind of like, okay, well, somebody else is the root bridge. And what else? They send out these BPDUs every 2 seconds. That's what we were discussing last night. So I was like, yeah, we need to go over some of these fundamentals here. The forwarding delay, 15 seconds, right? So we wait 15 seconds before we start forwarding. Remember when we changed the Spanning Tree topology, and then we did the listening and then the learning, and then it started forwarding. So there's a delay of 15 seconds before it starts forwarding traffic, right? Let's make sure. Congrats on 100. Yeah, appreciate that. I really would like to get to 5,000 subscribers. Well, that's something I really, that's a goal of mine right there. So make sure you like this video, make sure you subscribe to this channel and stuff too. But we're going to go over Boson Netsim Spanning Tree protocol in just a second here. There's also the maximum age timer. Remember, these are default timers. You can change these timers now. So for like the hello BPDUs, you can change it from anywhere from 1 to, I believe, 10 seconds. Let's look at that. Let's look that up real quick. Real quick. I think it's STP timers. I tried to look this up earlier too. There they go, right there. I went and Googled it. Yes, I'm Googling on my live stream. It is what it is, right? So hello, yep, we said 2 seconds, or yeah, every 2 seconds. Max age is 10 seconds. Is that what he said on that though? Let's see. He said 2 seconds. Max age is 20 seconds. I don't know what he got. 10. See, 10 times the hello. That's why. So it's not 20 seconds. It is 20 seconds, but what, 10 times 2, we know is 20 seconds. So that's the actual right there. But this is per geeksforgeeks.org. We really want to use Cisco.com. We want to get the white papers from the actual Cisco website because we're studying for Cisco exams, right? So we go to, let's do timers real quick. Spanning tree timers, and the default values of the timers are here. And max age, come on, default values right there. It takes into account the fact that the switch is at the periphery of the network, does not time out the root information under stable conditions. That is, if the root is alive. The max age needs to be taken into account, but blah, 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 blah. What in, y'all know I like to keep the simple true max age. Y'all know I like simple language, man. There was one that I found one that was a more simpler language. I think this is a good site too, OmniSec. We'll go over we'll do the lab in just a second. We got Aaron Neferli in the building, Creed 9 in the building. Appreciate you guys for tuning in. Aaron, I hope I pronounced your last name correctly, but sorry for butchering it if I did. So there we go. These are the definitions right there. Hello timer is the time interval between BPDUs. Each BPDU that is sent on a port. Default spanning tree is 2 seconds. You can adjust it anywhere between 1 and 10, just like I said. Forward delay timer, here is a better definition. The forward delay timer is the time interval that is spent in the listening and learning state. Default forward delay is 15 seconds. You can adjust this between 4 to 30 seconds. And the max age, finally, the max age timer controls the maximum length of time interval that an STP switch port saves its configuration BPDU information. Default is 20. You can tune this anywhere between 6 and 40. So it retains information about BPDUs, and it doesn't discard it until after whatever the max age timer is. And by default, it's 20 seconds. So those are the default timers we definitely want to memorize. And that's the ones we were discussing yesterday. Hello's every 2 seconds. Forward delay is every 15 seconds. And max age is 20 seconds. So yeah, shout out to packetlife.net. If you want a copy of these like cheat sheets, go on that website. I believe you'll see a link at the top that says cheat sheets. And it has like just cheat sheets for every topic. For CCNA exam, I guess you could use these for like CCNP too. So like I said, y'all know I like going over the fundamentals. So what else are the stuff that we should go over? I believe that are in this lab. That's pretty much it. We'll kind of go over it while we're doing the lab also. So the lab we're doing today is kind of, I think it's similar to yesterday's lab. I can't remember. We just got 4 switches here. We're just going to observe spanning tree in this lab, and that's pretty much it. I'll give you guys some time to let me get some late stragglers to come in. Network Prodigy has some great STP videos. Oh, okay. I haven't checked. Is that on YouTube also? Or is that like a website, networkprodigy.com or something like that? Let me know, Pete. But appreciate you for tuning in. What else that I wanted to look up here? Apple reports a 50% year-over-year jump in iPhone sales. That's interesting. So more and more iPhone users. I actually have an iPhone, but that's just because work issued me an iPhone. I'm an Android guy. I'm Team Android. What do you guys? Team Android or iPhones, man? I have an old LG Stylo. That's why there's a delay with my NetworkBruh sound effects. And this is my trusty dusty phone. I love my Android. I do have an iPhone also, the latest one or whatever. But like I said, that's just for work. And I let my daughter play with it and stuff like that with her games and stuff. But anyways, The company warned of coming iPhone and iPad supply constraints. And what is usually one of the slowest growth quarters in any given year, Apple today reported a nearly 50% year-over-year increase in iPhone sales, among other positive numbers that beat analyst expectations. The numbers were published today as of Apple's quarterly earnings report. They saw an $81 billion revenue in quarter 3 of 2021, up 36% over year. Basically, they made more and more money. The Mac and iPad also grew, albeit a smaller amount. The Mac generated $8.24 billion, up 16%, and the iPad was $7 billion at 12% growth. The other big number is Apple's other products. They put in quotation marks revenue, which primarily includes wearables like Apple Watch and AirPods. That category produced $8.7 billion, more than either the Mac or iPad, for 40% year-over-year growth. Analysts believe the continued rally can be contributed in part to the world's focus on work and home remote. Yeah, definitely. Work from home and remote classrooms, which have continued. The global COVID-19 pandemic has progressed into new phases and to some reasons. So yeah, I would say COVID-19 had a lot to do with the growth in their sales and stuff like that. Yep, YouTube. So yeah, I'll check it out. So yeah, let's go ahead and get started with Lab topology. PC1 and PC2 are PC workstations, as you can see, obviously. P1 and AS1 are access layer switches. So this right here is our access layer, right? Remember we said we got three layers in the hierarchy, 3-tier hierarchy: access layer, distribution layer, but we're missing the core layer there. So we just have a little local area network. And as they mentioned right there, 3 layers of the Cisco 3-tier or 3-layer hierarchy network model, which includes the core layer, blah, 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 blah. First, task 1 is to examine spanning tree. If you loaded this lab, blah, blah, blah. On P1 DS1, we're going to go to that switch right there. DS1, which is the distribution switch. Where is he at? Make sure y'all hit me with that like button. DSW1 right there. Issue to show spanning tree VLAN 1 detail, right? Remember, we have, depending on what version of spanning tree we're running, we have an instance of spanning tree per VLAN. This probably has this one VLAN, show span VLAN 1. They also said detail. And let me make this a little bit bigger so we're not too focused on that topology. I believe you can zoom out too, can't you? Yeah, you can. There, that makes it a little better. Y'all let me know if that's too small. But we really want to see the output here, right? Use the output to answer the following questions. Which spanning tree is VLAN 1 executing? I don't understand that question. Which spanning tree is VLAN 1 executing? Oh, there it is right there. VLAN 1 is executing the IEEE compatible spanning tree protocol. So I guess that is... See, I don't understand that question. Well, not that I don't understand that question. I don't understand what version of spanning tree they're saying here. So I think the question was, like which, because remember, there's different flavors of spanning tree. What are they? They are right here: Legacy STP, PVST, PVST Plus, which is Cisco proprietary. These are the Cisco proprietary ones. There's Rapid Spanning Tree. There's Rapid PVST Plus, and then there's MST. Right? These are all different flavors of spanning tree protocols. That would have been a better question for me. Now, which one are they running? It says running the IEEE compatible spanning tree protocol. That don't really tell me nothing there. I like to do, y'all know, I like to do, when it comes to spanning tree, I like to do show spanning tree sum. That tells me in plain English. Let's see what it says here. It says here we are running, see there, in PVST mode. That didn't tell us which version of spanning tree, but it says there it's executing the IEEE compatible spanning tree protocol. But right there, switches in PVST mode. So I don't know. I don't like that question. I don't know. But it does say it is executing IEEE compatible spanning tree protocol. So whatever. What are the priority sysid and MAC addresses? So priority, it says it right there. All this stuff is in order right here. So for VLAN 1 right there. VLAN 1 is right over here. Bloop. Bloop. Right there. Priority is 24576. sysid is 1. And the MAC address right there is right there. 000C 1461 3123. Remember, we said the priority, whoever has the lowest priority, or bridge identifier actually, is going to be the root bridge for that specific VLAN. Lavaris is on Team Android, had his Samsung Galaxy S8. Oh, Lord, I thought I had an old phone, man. I got an LG Stylo 3. I had this phone since, what, 2000 and, I want to say 2017, maybe? Maybe 16? I don't know, but that's an old phone, man. 2012, that's what's up, man. You probably root it and all and do all that stuff, huh? I guess legacy STP. I would think, but when we did show span some, it said we're running PVST mode right there, the IEEE standard. But it is compatible. It's backwards compatible with the classic legacy spanning tree. So it is backwards compatible, right? So they kind of like work with each other. So okay, that question is stupid. I agree. Sorry, folks up Boson. I hate to say that, but I don't know if I like that question. But it does. They're just taking the output and saying exactly right there because it has the keyword executing. So it is executing right there, executing the IEEE compatible spanning tree protocol. So it's compatible with the classic spanning tree, but we are really in PVST mode, as you can see right there when you do show span sum, right? So, and let me see right here. It says, let's see, we're running PVST, right? So we said PVST, yeah, PVST mode, which is right there. Legacy ST is the algorithm that we're running. So anyway, sysid, we said it's 1 because it's VLAN 1, right? Where is he at? Right there, sysid 1, and then the MAC address. We already answered that question. Why is there no root port? Anybody know why there's no root port? It says right there. We are the root bridge of the spanning tree, so therefore there is no root port. There's no root port. A root port is the port that'll take you to the root bridge, but we are the root bridge, so therefore there is no root port. Y'all get that? You know, if you have any questions, let me know. Ask in the chat room. There's a lot of smart people in the chat room that'll answer if I can't answer it or whatever. So why are there no block ports for VLAN 1? Same thing here, because we are the root bridge. A root bridge, and we discussed this yesterday too, all the ports are forwarding, right? We can verify that with just show, well, they want us to do this right here, show span VLAN 1 detail. But let's see. See, this tells us the block ports. Does that one tell us block ports? Let's see. Nope, it doesn't tell you. There's no block ports. There's nothing in here that says there's blocking when you use that. But if you want to see specifically block ports, you could do show span sum, tells you which ones are blocking. We have none blocking on VLAN 1. See that? Because we are the root bridge. We're not going to be blocking any ports. All of our ports are going to be forwarding. We can verify that with show span VLAN 1 without the detail, and we'll see right there. All forwarding. If one of them was blocking, they'll say BLK right there. What is the timer value for sending BPDUs? Bridge Protocol Data Units. We just discussed that about 10 minutes ago, right? We said the defaults right there. The default, hello, is every 2 seconds, right? But let's see if they left it at default. Let's see. We go to show span VLAN 1 and then add the detail keyword at the end. And we'll see. They wanted to know what is the timer value for sending BPDUs. I think it's that right there. No, there it is right there. Configured hello time 2. So we're sending BPDUs every 2 seconds. Next question, what is the maximum age for BPDUs? Right there, 20 seconds. And then the next question right there was the value of the forward delay timer, 15 seconds, which was just discussed. So they're all left by default right there. There's the timers. 2 for every hello BPDUs every 2 seconds, forward delay every 15 seconds, and maximum age. We retain information about BPDUs for 20 seconds before discarding it, or assuming that we're the root bridge, etc. We got Professor Black Ops in the building. Appreciate you for tuning in. He's got the stick of the day. Network device must use SNMP version 3 security with FIPS 142 validated cryptography for any SNMP agent configured on the device. FIPS is validated encryption checked by the government. That is food for thought for y'all. Y'all know what STIGs are, right? Security Technical Implementation Guides. Those are kind of like, how we say, compliance that DoD companies and government companies need to follow and stuff like that. So appreciate you for tuning in, Professor Black Ops. If you guys want to get into like some cyber security and stuff like that, y'all make sure y'all check out his channel. And he usually pops in and gives us the STIGs of the day right there. So that is STIGs of the day. Although we're not doing SNMP today. Today we are doing spanning tree. But didn't you give us a spanning tree STIG not too long ago? But that is food for thought too, though. Devices must use SNMP version 3. And it's funny you mentioned that. On my on my current job, I had to upgrade all the layer 2 from SNMP version 1 to SNMP version 3. That is a more secure protocol, as Professor Black Ops stated, because it has better encryption and stuff like that. So and less vulnerabilities. What else they want to know? We're on right here. On P2 ASW2, issue the same command right there. Show spanning tree VLAN 1 details. So we're going to go to that other switch, which is over. We checked out AS. We checked out DS1. Now let's check out AS2. That one. That guy right there. Bloop. Right? P2 ASW2. Let me make sure I'm on the right switch, right? Show span VLAN 1 detail. So I guess we're just doing show commands on this lab to display the following. Display the spanning tree VLAN for a spanning tree for VLAN 1. What are the prior? So same question here. So what are the priority, sysid, and MAC address for VLAN 1? We go up to VLAN 1 is the interface. There it is right there. VLAN 1 is executing that. The bridge identifier is 32768. Keep up with this. I'd like to keep up with this. Oh, okay. Yeah. Some work stuff, y'all. We'll close that. Let me answer that on the other chat. So anyway, so default is 32768. sysid is 1. And MAC address is that. What's the next question? What are the priority and MAC address of the root bridge? Okay, so this is information about us. And here's information about the root bridge right there. Current root has a priority of 24576, so lower priority than me, right? And his MAC address is that, different, right? So that means that's indicative of somebody else being the root bridge, not us, right? That makes sense? I did give a spanning tree stig before in another live stream. Yep, you sure did. We're just doing a little bit more spanning tree. I guess we love spanning tree. We're getting our fair share of spanning tree. Don't worry, we'll move on to other topics. I think after a whole bunch of other spanning tree stuff, we're going to do, I think the next thing we're going to be doing is more OSPF stuff. So what is the root port? Right there. What is the root port? Root port, it says right there in plain English. Root port is 2. What does the 2 mean? It's port number 2, FA01. The cost of the root port is, root path is 19. Now, why is it 19? There's default values or default costs for different types of ports you have, right? And again, we'll go defer to our cheat sheet here. These are the link costs. If you have a gigabit Ethernet port, cost is 4. We are running, it says our cost is 19, so this lets us know that it's a fast Ethernet port, right? Which lets us know it's 19, right? So default values are, now you change the cost now, but default for fast Ethernet, 100 megabits per second is 19, right? So that's why the cost to the root bridge is 19, right? What else can we say here about that? So cost of root path is 19, and it's FA01. Another question. What is the cost? No, we already answered that. What are the configured values? Jesus, y'all give me a second, man. Unbelievable. Y'all give me a minute, man. Y'all give me a minute. Okay. All right. For 2E, rather. Y'all got any questions so far about spanning tree or anything like that? We're just kind of going over the basics and stuff. Shout out to the good folks at packetlife.net. If you want these spreadsheets, they got, like I said, they got spreadsheets for like a whole bunch of topics. Spanning tree, OSPF, EIGRP. So this is like cheat sheets. These are applicable to CCNA and Encore and also in RC. So we need to know our fundamentals before we start, moving on to the more advanced topics and stuff, right? What are the configured values for the hello time, max age, and forward delay? We also said that the default, Fuck is wrong with me, man? Hello timers are for beep or BPDUs is 2 seconds, forward delay is 15, and max age is 20. I'm gonna keep saying that until I memorize this shit, right? So what are the configured values? Configured, right there, it says right there, in plain English, configured is hello 2, max age is 20. This is also known, the hello time is also known as BPDU timer, right? Max age is 20, forward delay is 15. This is a tricky question right here. Are these timers that are in effect, are these the timers that are in effect? Why or why not? We discussed this yesterday. They are not in effect. So we are on this guy, right? A P2 ASW2, which is that guy right there. Bloop, that guy, right? And move him over, right? This guy right here. But we said that this guy is the root bridge, right? This is us and our configured timers right there, right? And in the root bridge, this is his information. But the timers are determined, or how do I say this? Yeah, the timers are set by, are kind of like governed by the root switch. So even though we have a configured timer of BPDUs, 2 seconds and 20 and forward delay 15 or whatever, it's the root switch on the network or on the STP topology for that VLAN. He's the one that determines what the hello timers are, the max age and the forward delay, right? Now I'll even show you right there. So this is the tricky question right there. I like that question that they gave us that right there. So what was that? 2F, right? So we go to 2F. Remember, and that's what I love about this application too. If you don't know the answer, they give you the answers like in the back of the book at the bottom right there. These timers are not in effect. The timers that are in effect are the timers advertised by the root bridge. So this is what we have configured on our local switch. But the ones that are advertised by the root switch are the ones that are like, it's like the rules basically. So they are the same. Jesus, they are the same, but the root switch is the one who determines the real timers and stuff like that. Y'all got any questions or anything like that so far? Let's see here. Yeah, so these the timers are not in effect. Yeah, that's pretty much it. One thing we could do is, we didn't really do anything. We just did some show commands. So let's grade this lab right here. We didn't do any configuration, so that's why it says we completed the lab successfully. They just wanted to observe and stuff like that, what's on the network. Y'all make sure y'all hit with that like button. Make sure y'all subscribe. I will be, again, giving away a copy once I get to, of this application. Once I get to 5,000 subscribers, my goal is to get to that by the end of, I guess, I wanted August, but may or may not happen, but whatever. I will give away a copy of this application here. Let's move on to the next lab. I wanted to do another lab here. Let's see. Great lab. No. View. Windows. Labs. We're going to do, we just did the spanning tree, that one. Let's do this one. PVST load balancing. We've done a couple of load balancing ones. And then maybe if we got time, we'll do the port fast one, the troubleshooting one. That'll wrap up all the spanning tree ones. And then we'll move on to OSPF stuff. The routing protocols. That's what I want. I couldn't wait till we get to that, man. I'm getting kind of tired of spanning tree. I don't know about y'all. Are we on that? Did we load it up yet? There it is right there. Spanning tree protocol, PVST load balancing. They're going to have us create a VTP management domain for the distribution of VLANs to all switches. Configure a primary and secondary root bridge for the VLANs in the network. So we got a couple more switches, bigger topology and stuff like that. Y'all got any questions or anything? Y'all just kind of quiet over there in the chat room. Let me refresh, because I know sometimes I got to refresh and then I'll see some of the chats in there. So yeah, packetlife.net. Make sure you get you a copy of these cheat sheets here. Shout out to Jeremy Stretch for creating these, man. These been out for years too, because I remember like studying for like Network Plus exam, and they have this stuff. So what we want to say about PVST load balancing. I don't think they put anything in the spreadsheet there, but here are some fun facts about PVST. It's running the legacy spanning tree protocol, the spanning tree algorithm. It is a Cisco proprietary. Are we doing PVST or PVST Plus? That's the question. I guess it's just PVST. So that's Cisco proprietary. Per VLAN instances per VLAN, right? That's why they call it PVST. So we have an instance of span tree per VLAN, right? So for example, right here, and this is, we're going to do something similar to this right here, right? We could have one switch to be the root bridge for us, a couple sets of VLANs, and then we can have another switch to be the root bridge for another set of VLANs, right? And then that's how we kind of load balance our traffic. So all of the VLAN 10 traffic is going to go that way, and VLAN 1 traffic is going to go that way, and then all the VLAN 20 and 30 traffic is going to go that way before exiting out to the, out of the local area network, right? What else we want to say about that? We could also have, what we're going to do here, a primary and a secondary root bridge, right? So we'll have, like, this could be the primary root bridge for 1 and 10, but it could also be the secondary root bridge for 20 and 30. So in case this guy right here dies, in case switch B dies, then all of our traffic for those VLANs, this guy will assume the root bridge for VLANs 20 and 30 as well, right? Until he comes back up or whatever, right? And we'll know he's dead by those BPDUs. We're not getting any more BPDUs from the root switch. Okay, then we're gonna assume the root switch for those specific VLANs or whatever, right? Okay. Where we at? Yeah, let's go ahead and get started. Task 1, perform the initial configurations. Configure the links between the access switches, ASW1 and ASW2. Where's he at? There's ASW1 and ASW2. He said configure the links between the access switches, ASW1 and ASW2, and the distribution switches, DSW1 and DSW2, which is these guys right there. So we got access layer, distribution layer, and core layer, right? Let me move these guys over so y'all can see them, right? Bloop. And move them over. Bloop. Shout out to Lavaris in the building. Appreciate you for tuning in. He said, off the topic, random question. Do you think networking is evolving as fast as programming today? Really, really, really good question. I don't know. There's no way to really quantify that, I don't think. I mean, you could, but, like, for example, we talked about the growth of, Apple reports a 50% year over year jump in iPhone sales, right? And they said, why? Because of COVID-19. And we got a lot of people working from home and stuff like that. What do they rely on? VPN services, networking and stuff like that. A lot of this work from home, like, the world is changing as far as, like, just the workplace in general. We have a lot of people that's, like, working remote now. How's that all possible? Because of networking. Not necessarily programming, because of networking. Networking allows them to work remotely. Like, how can we live without the internet? Remember we talked about the other day, like the lady who moved into her new home and she didn't have no internet and stuff like that. It's just like, now programming, how can I say that it grows as fast? I don't really pay attention to, like, computer programming or coding or anything like that. Can I say it's growing as fast? Maybe. I don't know. Like I said, I don't really pay attention, but I know networking is definitely evolving. Can I say it's as fast? I couldn't tell you. That's a really good question, though. If anybody else want to chime in, I took some coding classes in college, and that shit gave me a headache, man. I was like, I don't like this shit, man. I knew that software engineering and coding and stuff like that, you make some money in that, but I'm not gonna just jump into it just because they make money. So, I like computer networking. I'm fascinated about it, and I just feel like it's just something that I just love what I do. So, but that's a really good question. If anybody else wanna answer that question. I think is it evolving as fast as programming? It's probably evolving faster in my opinion. But then again, like I said, I'm biased towards networking. So y'all can't live without the net. Programmers can't live without networking, man. I ain't gonna say we can live without programmers, but it's because of networking. Applications. Layer 7 can't work without layer 3, man. Straight up. But anyway, configure the links. They want us to configure the links as trunk links. Let's see here. Let's go to ASW1. Enable. We're going to go to show interfaces trunk. Let's see who's trunking so far. we got ports 1 through 4 trunking using .1Q encapsulation. But we already got some ports right here that are already trunking. They said to configure them as trunk links using .1Q encapsulation. They are trunking right there. So, I mean, they want us to change the mode and hard-code it as a trunk? Maybe that's the reason. I don't know. Let's do that. I don't know. And if we're wrong or whatever, it'll let us know. Remember, when we grade our labs, that's what I love about Boson Netsim, is that we can do grade lab, and it'll tell us what we're missing, or if we added some extra commands. So, and it'll color code what we have extra. So let's just hard code ports 1 through 4 as a trunk. They're already using .1Q encapsulation. Let's do a show run too. Show run interface. What was that? FA01, for example, or FA0/1. Oh, yeah. See, it's not. That's weird. This doesn't have any configuration on it. But let's just hard code it as a trunk and then do .1Q encapsulation. Interface range FA0/1. That's what's weird right there. Switch port trunk encapsulation .1Q switch port mode trunk. And we want to actually do a range. So all 4 of those, 1 through 4, mode trunk and .1Q encapsulation trunk. So now all 3 of those are trunking. Now we'll do show interfaces trunk. Right? We've done trunking millions of times already. Now trunk mode is on. .1Q encapsulation. Same thing with ASW2. I guess we'll do the same thing there. Let's see. Is that trunking already though? Show interfaces trunk. Another thing I like about Boson, sound like a fucking advertisement for them, right? Is that we can just jump into, we don't have to necessarily do like there's initial configurations and stuff like that, but we don't have to like do host names or IP addressing, basic stuff like that. We just jump into the technology we want to learn. We want to learn about VTP, we jump right into it. We want to learn about OSPF, we jump right into it, right? So we just do like for example, Windows, Labs, right? And you want to learn about natting, boom, you just jump into a NAT lab, boom, and then you just kind of like work with it. So that's what I like about this application. So anyway, let's do 1 through 4 on ASW2. Hard code that as a trunk. Interface range FA01 through 4. Switch port trunk encapsulation .1Q. Switch port mode trunk. Right. Verify our work with what? Show interfaces trunk. And we'll see 802.1Q trunking. Good to go there. What else we want to know? Configure the links between the distribution switches and the core switches, CSW1 and CSW2, as trunk links using .1Q encapsulation. So they want to do the same thing between these links right here and these links right here. So we got a couple more that they want us to trunk. So on DSW1, let's see who's trunking so far. Show interfaces trunk. We've got 10 interfaces that are trunking. But some of them are using 802.1Q and some of them are using ISL. So maybe they want us to put all of them as 802.1Q. And then we'll hard code it as a trunk, because right now it's set to desirable. So we'll do 1 through 10 and have them all trunk, right? So global config mode, interface range, FA0/1 through 10. Am I losing anybody, or does anybody have any questions so far about trunking? We're just doing some trunking and stuff like that. We'll get to the spanning tree stuff in a little bit. Right now we're working with trunks, switch port, trunk, encapsulation .1Q, right? We've done this a million times on this channel, right? Switch port, mode, trunk. What else they want us to do? Same thing on DSW2. Well, let's verify our work, right? Like my boss always says, show interfaces, interfaces trunk. Trunking, 802.1Q. Some of them was in ISL. We got to do the same thing on DSW2. Enable global config mode. Y'all make sure y'all hit me with that like button. Once I get to 5,000 subscribers, I'll give y'all a free copy of this application so y'all can do it along with me, and we'll study together, man. Make sure you join my Discord server too. You copy an invite, and you'll know when if I cancel a stream or if I do any extra streams or anything like that. I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time, but sometimes I'll do some bonus streams or whatever. like on the weekend or whatever. But I'll have to let you know on the Discord server. So make sure you join that. On DSW2, we're going to do the same thing. Do show interfaces trunk, just so we can verify who's trunking and who's not trunking. We got 1 through 10. Some of these are 802.1q. The rest are ISL. So let's hard code that. Configure terminal. Interface range. FAST 01 through 10. Switch port trunk. Encapsulation .1q. Switch port mode trunk. What else they want to know here? Configure ASW1, 2, DSW1 and 2, and CSW2 to be VTP clients. Use the VTP domain Boson and password Cisco, right? Quick review on VLAN trunking protocol, VTP, right? Where are we at here? There's 3 modes, 4 modes, 3 modes, 4 modes. There's actually 4 modes. This is old spreadsheet. I mean, an old cheat sheet here. These cheat sheets been in the networking community for a decade, or a decade at least a decade, because I remember these a long time ago. But he says here there's 3 modes for VTP. Server mode, which generates and propagates VTP advertisements to clients. Default mode, it's the default mode for unconfigured switches. Server mode, right? Let's see what it is so far. Let's start with ASW1. Y'all know what the default mode is, right? Server mode. So show VTP status. And we'll see we are in server mode, right? There's the other mode, client mode, which is they want us to do with the rest of the switches. Receives and forwards advertisements from servers. VLANs cannot be manually configured in client mode. So who do they want in client mode? ASW1, 2, 1, DSW1 and 2, and CSW2 to be clients. So they're going to receive and forward advertisements from servers. Who's going to be the server? CSW1 is going to be server. So this guy right here is going to be the VTP server. These guys are going to be clients, right? And then finally, the last mode, transparent mode, which forwards advertisements but does not participate in VTP. VLANs must be configured manually. Now, there's also a fourth mode. What's the 4th VTP mode? That's pop quiz for today. I think I've asked that question before, but what is the 4th VTP mode, right? Because they're actually missing one there. Let's configure the rest of these guys as servers, and this guy's a client, and then the domain is Boson, password Cisco. So I'll do that while you guys get that pop quiz of the day. There, show VTP status. Go to global config mode. Global config mode. We got to go to privileged exec mode first, then global config mode, and we say VTP domain. He said is all lowercase BOSON. Oops, wrong. SON. And then the password, VTP password, is Cisco, all lowercase. And then they want us, the rest of these guys to be clients. So we'll start with ASW1. Any questions or anything so far? Am I losing anybody? Or remember, there's no such thing as a dumb question on my channel, man. Like, if I'm losing y'all, just ask away, man. I'll try to answer as best as I can and stuff like that. Pete said he don't know that one. So we said it was server mode, client mode, and transparent mode. There's one more mode for VTP. Show VTP status. He is currently in server mode. We need to change that to, I see that typo there. We need to change that. Global config mode. He is going to be in VTP mode client. And then VTP domain is Cisco. No, what was it? Domain is Boson. B-O-S-O-N. And then that was a typo there. Y'all see that? VTP password was Cisco. Yeah, I think we should do that. Now verify our work with show VTP status. VTP status. P said off. That is correct. Off is the last mode. So you can completely turn off VTP. Essentially, transparent mode is a way to turn off VTP also, but off completely turns it off. What we got here? So it's in client mode, Boson. We can only verify the password with show VTP password, and that tells us the password. Let's make this guy a client. What is he at right now? Show VTP status. We got to fix that typo. So let's global config mode, VTP domain is Boson, VTP mode client, and then VTP password with Cisco. We got to do the same thing on this guy, the bottom three right here, right? So global config mode, VTP, domain, Boson, VTP password is Cisco, and then VTP mode. He's also a client, right? Show our work, show VTP status. We'll get to the spanning tree stuff in just a second here, y'all. Last two switches right here. Come on, bro. Show VTP status. We need to fix that typo again. VTP domain is Boson, right? VTP password Cisco, and VTP mode is, we said, client. One more to go. Show verify our work, show VTP status, and client mode Boson, and leave the password is correct, right? I'm sure the password is in there. And then last switch right there, enable global config mode, and we said let's check what he's got so far. He needs to be, see that spelled wrong? See, I had a little typo there. VTP mode client, VTP domain is Boson, and then VTP password Cisco. And then that should be it for all of them, right? And then we configured that guy as the VTP server. Then it says create VLANs 2, 3, 4, 5, and 6 on CSW and verify that these VLANs are propagated to each switch in the network. So basically, we're going to create VLANs on there, and then they should be propagated to all of these other guys, right? So let's just check ASW1 real quick. You see what VLANs he know of. Show VLAN brief, and that's the point of VLAN trunking protocol, is a way to, minimize the administration of VLAN creation, right? So that way we don't have to create VLANs on every switch. We can just create it on one switch and it gets copied onto the other ones. That's what VTP does, right? Except it does it over trunks. That's why we had to create the trunks, make these links trunks first before we worked with VTP and stuff like that, right? So right there. Do they have a better definition for it? I guess not. But that's what we're working with, VLAN trunking protocol right now, right? So let's go to CSW1. And then we're going to go to global config mode, and we say VTP, I'm sorry, what was he going to do? VLAN. We got to create a VLAN. VLANs 2, 3, 4, 5, and 6. And then verify that they're propagated, right? So we're going to create those VLANs. Bloop. Do we got to put a space in between all those guys? What we got to do? Space, 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 space. No. How can you create multiple we'll just do 2, 3, 6, right? Can we do that? 2, 3, 4, 5, and 6. And 6. Let's do 2 through 6 like that. No, you can't. Can you put a space in between that? No, you can't. Isn't there a way? Come on, man. I know that there was a way to do that, man. VLAN 2. I thought you can do more than one VLAN, man. Y'all know we could do that, man. Come on, man. Pete said VTP version 3 added off mode and per port VTP configuration. That's good to know. So version 3 came out with the off mode. Good to know. Good to know. That's another fun fact that we need to try to remember. I thought we can do 2 through 6. Don't tell me I got to do this one at a time, man. That's crazy, man. Come on, man. Now we've added VLAN 2, VLAN 3, VLAN 4, VLAN 5, VLAN 6, exit, and then VLAN 6 will be created. Do show VLAN brief. I got 2 through 6 there. Now we're gonna go to AS1. And remember, he only had the default VLANs, which is VLAN 1, and then 2, 3, 4, and 5. We do a show VLAN brief, and we should see, there they go right there, 1 through 6. Good to go there. So, and we verified that they propagated to each switch on the network. Verify the VLANs 2 through 6 have been published from CSW1 to all other switches. So now they want us to check. I'm not going to check all of them. I'm just going to check one random one, and then we'll move on to the next task. Show VLAN brief, 1 through 6, and there they go right there. Right. So let's go to task 2, plan primary and secondary root bridge configuration. Your network engineer has determined that VLANs 1 through 3 represent half of the traffic on the network, and that 4 through 6 represent the other half. He also noticed that a majority of the traffic is concentrated on communication between the workstations on the network and not out of the internet. So basically, that's why we're gonna pick a primary root bridge and a secondary root bridge for each of those VLANs. How is the information provided by the network engineer useful? Well, we can say, if we know half of our traffic is going through VLAN 1 through 3, then we can say, okay, we want that traffic to go over here. And then the other traffic represents VLANs 4 through 6. We can say, okay, we want that traffic to go all over there. So that way, not all of it is being congested on the one switch. Because remember, all of our traffic needs to go to the root bridge first before it goes out to the internet, right? Well, what if everybody's going all out to the same root bridge? Well, we want to separate that. That's how we kind of like, it's like we're traffic cops. As a network engineer, we have to like segregate or kind of like control our traffic. So that's why it's useful. What can you do to load balance the network? And that's just like what a traffic cop does, right? Okay, some of y'all go this way when the light is broken, right? And the street light or something, and the cap's going to let some of these cars go by, tell them to stop, and they say, okay, y'all can come, right? And he sees enough traffic go there. Okay, y'all stop. Okay, y'all go. That's basically what we're doing with load balancing, right? What can you do to load balance the network while not giving up redundancy? Same thing here, planning a root bridge for one mile traffic, primary root bridge, and a secondary root bridge. That's one way to load balance. On each switch, determine the spanning tree root status. Which device is the root bridge? Well, that depends. What VLAN are they talking about? And they want us to do that for each switch. God damn it. Whatever. Let's start with ASW1. So let's see who's the root bridge for VLAN 1. Show span VLAN 1. Right? We see the root bridge. Looks like we are the root bridge for VLAN 1. So ASW1 is the root bridge for VLAN 1. Let's take a look at ASW2 and see who is the root bridge for VLAN, I don't know, 2. Show span VLAN 2. Looks like somebody else is the root bridge for VLAN 2. So it's not him. Let's see if it's him. And I'm not going to go on all of them for every VLAN. That's a lot of VLANs, right? I'm just going to do this until we find out who's the root bridge for VLAN 2, and then we'll move on. Show span VLAN 2. Definitely not him. But we see that our root port to get there is FA01. And we are on DSW1. So which one's FA01? I think is that one? Oh, no. Well, let's check this guy and see if that's him. Show span VLAN 2. He is not a root bridge. He's probably going to be it. If it's not, then it's going to be core switch 1. Show span VLAN 2. Not him, so it's probably CSW1. Let's see. Pray to the network gods. Show span VLAN 2. And it is not him. Interesting. Who is the root bridge for VLAN 2? Did we skip one? It wasn't him. It wasn't me. It wasn't me. Was it me? Was it him? Who was the root bridge for VLAN 2? VLAN 2, VLAN 2, VLAN 2. There it is. No, that's VLAN 1. Oh, he might be the root bridge for VLAN 2 as well. ASW1. Let's see. Show span VLAN 2. Yes, he is. So it looks like he might be the root bridge for all of them. Let's see. And I guess that's why they did that for us. Make us check. VLAN 3. Yes. So he's probably the root bridge for all the VLANs. Right there. On each switch, determine the priority for all the VLANs. And it's right there. We got 32771 for VLAN 3. 32770 for VLAN 2. And then for VLAN 1, the root priority is 32768, the default VLAN. But we are the root bridge also, probably because we have a lower MAC address. He said, definitely can on hardware. You should be able to create VLANs 1 through 6 on one line, said Jay McLeod. Yeah, that's what I thought too. I think maybe just on Boson Netsim, you can't do that. Remember, Netsim is a network simulator, so it just simulates the environment of iOS. It's not real application, it's not real, how do I say? It's not the real iOS. It just simulates the environment. So yeah, I think you're right, Jay McLeod. You should be able to do VLAN 1 through 6, and you should be able to create all VLANs at the same time. But you can't do it on this application because, like I said, this is a fake application. It's not the real iOS, if that makes any sense, right? What's the next question here? How can you evenly split up the network traffic using the information you were given by the network engineer? Well, we pick a different root bridge for each VLAN, right? And if we don't know if we answered that correctly, we could go to the bottom of this and see, right? So task 2, question 5. Let's see. What did they say the answer was? Task 2, question 5. They said you can evenly split up the network using information from the network engineer by assigning each group of VLANs to traffic through one set of switches, which is basically what they're going to have us do. What's the next one? So we got 4 tasks, and then, yeah, 4 tasks. We are on task 3 now. Implement and verify primary and secondary root bridge configurations. That's a lot to read here. I don't want to read all this to y'all like y'all in 3rd grade and shit. In order to balance the load, here, let me read this myself. Redundant links are network level resiliency. Cisco defines 3 components of high availability solution: network level resiliency, system level resiliency, network and monitoring. In addition, blah, blah, blah. You should also configure management protocols such as SDP to ensure redundant links do not generate loops within the network. In order to balance the load, you should designate each of the distribution layer switches as root bridge for half of the VLANs. So right here, they want us to say, they want to do this. Configure DSW1 as a root bridge. So DSW1, this guy, to be the root bridge for VLANs 1 through 3. And DSW2, that guy right there, to be the root bridge for VLANs 4 through 6, right? So right now, this guy is a root bridge for all of the VLANs. So all of the traffic must pass through him before they go out to the internet, right? We don't want that because we can cause a bottleneck, right? All the traffic. So in other words, if this guy needs to send traffic, he's going to go like over here and probably over here and in there, and then go to the default gateway, right? Same thing with this guy. He has to go send all of his traffic there before it goes out to the internet, or that way, whatever. Well, we're going to split that traffic. This is going to represent the root bridge for one half of the VLANs. This is going to be the root bridge for the other set of VLANs. And notice they pick the distribution layer. You definitely want to make the middle of your network, or at least the core of your network, to be the root bridge, somewhere in the center of the network. So make it go to the center of the network before leaving to the internet, right? That make any sense, you guys? Pete said, with this topology and in general, shouldn't the core switches be the root? Very good question. Very good question. You would think, because they're the core switches, right? So I like that question. Here's our core layer right here, right? You would think all of the traffic should be there. No, theoretically, you want to put it at the center of the network, is what they usually say for spanning tree. You want to put it at the center of the network. The core kind of like resides at the edge of the network. You don't really want that to be the root bridge for your spanning tree. It's usually the core, the center of the network. I know it sounds kind of, how do I say, like oxymoronic, right? Because we said this is our core layer right here, right? The core is not necessarily the middle of the network. The middle of the network in this case is the distribution layer. So that's why they made it the middle of the network, this guy right here, these guys right here, to be the core of the network. So this is going to represent our spanning tree roots. That makes sense? But I like that question, Pete. Let's see what they say to break that down, right? Task 3, question 1, right? Task 3, question 1. Let's see what they explain there. I like that question. Task 3, question 1. You should issue the following. They just tell us how to do it, which we already know how to do as a root bridge. Yeah, they didn't really explain, but usually you want to put the root switches to be kind of like the center of your network, right? Unless anybody wants to explain a little bit more or has a better explanation for that, y'all let me know. But we want to go to DSW1 and make him the root bridge for VLANs 1 through 3. So we go to DSW1, we go to global config mode, spanning tree, VLANs 1 through, we got to do a space, I believe, 3. And then, can you do it that way? Let's see, spanning tree 1 through 3, like that. Don't look, you can. Don't look, you can. Can you do 1 through 3 like that, and then say root primary? Yes, you can. There you go. So you can have to put a space there. So that's going to make him the root bridge for VLANs 1 through 3. Bloop. And then DSW2, right there, it says DSW2 is the root bridge for VLANs 4 through 6. So 1 through 3 is going to go through here. 4 through 6, DSW2 is going to go through DSW2. VLANs 4 through 6. So we do the same thing, but VLANs 4 through 6 on this guy. So spanning tree, VLANs 4 through 6, root primary. So he's going to be the primary root bridge for VLANs 4 through 6. And then they said, on each distribution layer switch, display the spanning tree priority assigned to the root switch for each VLAN. Is the spanning tree priority the same for all VLANs? Why or why not? So let's go to DSW1. Y'all got any questions so far? Anybody else want to point anything else out? So span, P said, thanks. Yeah, I think that's what it is, man. You really, when you're designing the network, when it comes to spanning tree now, the middle of your network, somewhere in the, like physically in the middle of the network is where you want the core to be, not necessarily the edge. So spanning tree, he said, what he said, the root switch. So spanning tree root, can you do it that way? No. Root primary? Priority, no. That's not what we want. So spanning tree root detail. No, that's not what we want. Let's see. What was the question again? Y'all hit me with that like button, man. Y'all hit me with that like button. Subscribe to the channel. We typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. I don't know. This might be the last lab we do today. I don't know. Y'all let me know. Unless y'all want to do another Boson lab, or y'all want me to fire up GNS or even G and we'll do a freestyle, whatever. It don't matter. For is the spanning tree priority the same for all VLANs? No. We got the spanning tree priority is 24582 for VLAN 6, 24581 for VLAN 5, 24580 for VLAN 4, etc., etc., etc. Why or why not? Well, that's because of the system ID, right? So it'll be the priority in this case would be 24575 or 2457 and then the, how do I say this? They add the system ID to it. That's why it's like each number is incrementing there. So 24576 plus 2 gives us 24578. That's why he's the priority for VLAN 2. Plus 3, so 24576 plus 3 for VLAN 3 is 24579, right? Because the system ID. Well, let's go to spanning tree right here. Spanning tree, system ID. Does he explain anything else about system ID here? System ID, system ID, system ID. I thought he had stuff in here for the system ID. Or at least there it is right there. 12-bit value taken from VLAN number. That's what we're looking at there. So it's the priority plus the system ID. That gives us the priority number. I mean, yeah, that gives us the priority number. So priority, or in this case, priority 24576 plus the VLAN ID. That's why these numbers are different. But let's see how they explained it, though. So task 3, question 2. Task 3, 2. Task 3, question 2. He says on issue, you want to do this right here. Also, show spanning tree root priority. That's how we do it. That's the best way to do it. So show spanning tree root priority, which is I was already there. That's the priorities for each of the VLANs. The spanning tree priority for all VLANs is 24576. You should note that the priority shown in the output is automatically incremented upward by the amount of the VLAN number, with the exception of VLAN 1. The priority changed from 32768 to 24576 when they were configured as a spanning tree root for primary for the VLANs. When you issue the show spanning tree or spanning tree root command, the switch checks the switch priority for each of the root switches for each VLAN in the VTP domain. By default, the switch will set its own priority for the specified VLAN or VLANs to 24576. If this value is lower than the current priority configured on the root switch for the specified VLAN or VLANs. Blah, 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 blah. What he said? We got Zai in the building. Hey, fam, I appreciate you for tuning in. Makes me want to do ENSLD in the future to get a good bird's eye view of everything. ENSLD, is that the What is that? I know that's one of the Cisco exams, but that's not SD-WAN, right? I can't remember what exam is that? Designing enterprise networks. Oh, okay. So that's that's one of their other harder exams, CCNP exam. I don't know. I like sticking with route switch, but let's move on. Next question or configuration was, we at test 3. For each group of VLANs, make the other distribution switch the secondary root bridge for each set of VLANs. This will enable the other distribution switch to become the primary bridge in the event the primary fails. So remember, we made this guy the root bridge for VLANs 1 through 3, and he's the primary root bridge for VLANs 4 through 6. Well, now they want us to do the opposite, right? So they want to make this guy the secondary root bridge for 4 through 6, and he's the secondary root bridge for 1 through 3. Does that make sense? It's designed. Okay, cool. So DSW1, we're going to make him the secondary root bridge for VLANs 4 through 6. How do we do that? So span VLANs 4 through 6 root secondary. And then he's going to be secondary for 1 through 3. So spanning tree VLANs 1 through 3 root secondary. Y'all with me so far? Verify that DSW1 is the root bridge for VLANs 1 through 3. So we're going to go through here. And I think we did that already, did we? VLANs 1 through 3. Show span root. Priority. Nope. Let's just do show span root. Not detail. Cost, address, port. Priority, no. Port, no. Path, cost. The MAC address of the root bridge. Can we just do address and see? Address. So span tree root address. My bad. Root address. And is that my address right there? 3538. We could do this. Show span VLAN. Let's just do show span so we can see all of them right there. We are the root bridge for VLAN 1, VLAN 2, VLAN 3, and somebody else is the root bridge for VLANs 4 through 6, right? 4, 5, and 6. Somebody else is the root bridge, which is most likely this guy right there, right? Let's verify that, right? Show span VLAN 4. This bridge is the root. I'm not going to do 5 and 6. So what's the other one? Verify the DSW1. Okay. DSW2 is the root bridge for 4 through 6, which we just did. I just did 4, but let's do 5 and 6. Let's do 5 and 6, just in case somebody asks, right there. He is the root bridge for 5 and 6. Right there. This bridge is the root. Y'all see that? Determine which switch is the secondary root bridge for the VLANs. That's a good question. What show command is going to let us know we are the secondary root bridge for, like, for example, how can we verify he is the secondary root bridge for VLANs 4 through 6? How can we verify that? Y'all know? Do we do show span root? Nope. Interface. Let's see. Let's do root. No, you can't do root by itself. Detail. We need to find out how are we the secondary root bridge. We are clearly the root bridge for the first 3 VLANs, but how do we know we're the secondary root bridge for the other VLANs? Other than by looking by the priority. Does anybody know? Does anybody know a show command that's going to let us know we're the secondary root bridge? I don't want to look at the answer guide. I want to get an answer from y'all. Make sure y'all paying attention, or make sure I'm not losing y'all or anything like that. While somebody gets that going, what's the next question? Last question right here. Determine which switch is the secondary root. Briefly explain root ports and designated ports. So root port, remember we said, is a port that takes us to the root bridge. So we know that this guy's a root bridge and this guy's a root bridge. But root bridges, all of their ports are forwarding and designated. What's a designated port? It's a port that's not a root switch. Not a root port, and it's not blocking. So therefore, it's a designated port, right? We'll see what his ports look like, right? They're all forwarding and all designated, right? That is the role. Now, let's say this guy's gonna have a root. He's gonna have a root bridge. He's gonna have a cost, or he's gonna have a root port, a port that's gonna take him to the root bridge for all the VLANs. So we know that this guy's the root bridge for VLAN 1. So which port is he gonna take to that switch, right? Let's see. Show span. Oops. Show span. Jesus, I can't even fucking type. Show span VLAN 1. One of these is gonna be root FA03. So it's probably maybe that one right there. I don't know. One of them takes us to the root switch, which is that guy for VLAN 1 now. For VLAN 1. That is a root switch. A designated port is a port that is not blocking. That's not a good that's not a good definition. Let's see what they say. I forgot what designated ports are. I ain't gonna front. Let's see. Task 3 designated port. Every non-root switch has one root port. The root port on a switch is the port that receives the best BPDU, best bridge protocol data unit, BPDU, which indicates the best path to the root bridge based on the best root port cost, which I semi-explained like that. A root port is always in the forwarding state. Because there is only one best path to the root bridge, a switch cannot have more than one root port. Only the root bridge does not have a root port. Switches may have one or more designated ports, and some switches might not have any designated ports. One designated port is selected for each segment. The designated port is the port that is closest to the root bridge based on root port cost. In the event of a tie, the port on the switch with the lowest bridge ID becomes the designated port. So we have a couple designated ports there. So designated port is normally on the forwarding state. All the ports on the root bridge are designated ports. Now here's a funny one right here. This one's designated, but it's also blocking. So the designated port concept kind of confuses me sometimes. But anyways, what is the next task? Do we have any other tasks? I think that's pretty much it for this lab, right? I think that's pretty much it. Let's see. They just wanted to run some show commands. We put those in the VTP domains. Then they just wanted to do some documentation. It's good practice to document your network. They want us to see how many root ports can each. I'm not going to do this documenting here. What path will VLAN 1 take from AS1? I'm not going to do all that. Let's just grade the lab real quick. Pray to the network gods and hope we configured everything correctly. Looks like we're missing some commands on the. Oh, I didn't put any of the core switches to trunk, I bet. That's why we got some red X's here. Let's see. Core switch 1. Yep, that's what I thought. So these guys are not trunking. That's basically it. So we trunked all these guys. The other guys need to be trunking as well. So let's go to the core switch. Make those. So we didn't do any trunk. We did the trunking on all these guys. We didn't do no trunking on those two guys right there. No, my bad. The core switches, right? I said the core switches, or not the routers, the core switch. LiveLabs core switch, yeah. So let's go to the core switches and do the trunking. Show interfaces trunk. Let's see what we got. Ports 1 through 8. So you notice we have different encapsulation, and they're in desirable mode. They wanted the ports 1 through 8 to be 802.1q. So did they tell us to do that last time? Let's see. Did we skip that step really? Let me go to the top. We did. Oh, right there. And the core switches. That's what I was missing. I didn't pay attention right there. So we didn't make those trunks. So interface range FAST 0, 1 through 8. Is that 1 through 8? Yep. And then switch port trunk encapsulation .1q. Switch port mode trunk. Same thing with these guys right there. I believe it's 1 through 8, right? Come on, wake up, man, wake up. Show interfaces trunk 1 through 8. Interface range FAST 0, 1 through 8. Switch port trunk encapsulation .1q. Switch port mode trunk. And I think that was pretty much all of them, right? That should be it. Let's verify our work with show interfaces trunk, and we'll see trunking mode is on. 802.1q encapsulation, and they're all trunking. Grade our lab, get on our knees, pray to the network gods, and we've completed the lab successfully. That's what I love about Boson Netsim. In case you're missing some stuff, it'll tell you here's where you fucked up at. Y'all make sure y'all hit that like button. Make sure you subscribe. I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. We're semi-following this spreadsheet. This is kind of like a study plan for the Encore exam. Like I said, I don't have to take the exam. I'm just like, I like going over the fundamentals, and I'm like passionate about networking and stuff like that. So, but I do have to take an elective exam in order to obtain the CCNP certification. So, and I like going over the fundamentals and stuff like that. If you want to copy this spreadsheet right here, everything that we covered, we highlighted in green, but I don't think I put any of the Boson. That was the spanning tree labs right there, but we did way more spanning tree labs than that. So I don't know what this was from the old version. I was going to do a switch lab from that. I need to revisit this one because I need to go over VLAN ACLs. That was sort of a new topic for me. So we did that lab, but I kind of like stumbled through the end where they, introduced the VACL concepts for me. So I need to go over that. I definitely need to read chapters 2 through 4 for spanning tree. So if you want to copy this spreadsheet, make sure you join my Discord server. Here is a link. This is an invite for it. He said, what is the secondary root solution? Oh, good question. Good question. Let's see what they said. What's the show command that's going to tell us who is a secondary root bridge? Secondary root bridge. Let's see. Let's see. Let's move that over. Glad you caught me before I finish the stream. Unless y'all want to do some more labs. It's only been a little bit over an hour. Show spanning tree. No, that's going to tell us the priority. But we want to see who is the secondary root bridge. We did that. I guess you just got to do, let me see, let me verify. What was that question? Which number was that question? Determine which switch is the secondary root bridge is task 3, question 5. So we go to the bottom, task 3, and they said question 5 right there. Oh, you got to run the show run to see it. And that lets you know who is, so there's not really a show command that let us know. You actually just do a show run to see, and then you see who is it really? There's got to be a show command to let us know who's a secondary. I guess you just got to kind of like do process of elimination and then see. You should issue the following to determine the secondary root bridge. Show run. That's it right there. And y'all know I try to stay away from doing show run, but apparently there's no like show command that's going to tell you specifically who's a secondary root bridge. So you just got to do show run, and you'll see. Right there, that lets us know secondary root bridge. I guess that right there lets us know. Damn it, show run, right? I know. Task 3, part 5. Yep, you're right. Let's turn that off. Y'all want to do another lab? Y'all let me know. It's random. Come on, man. Now this shit got ads and shit, man. This shit killing me. Off. Killing me, man. Anyway, y'all make sure y'all subscribe. He said show run just tells me what I typed in before. Exactly. That's exactly what I was thinking. He said wasn't expecting that. I don't know. Yeah, show run just tells me that's what I typed, but that doesn't necessarily say in plain English who is a secondary root bridge. I don't know. I want to go through some more labs. Y'all want to do some more labs from Boson? I like Boson, man. View, Windows, labs. I wanted to do maybe another spanning tree. I wanted to knock out these spanning tree labs. We only got 2 more. 2 more. Nah, we'll save them for tomorrow, man. We'll save them for tomorrow. Port fast and uplink fast, and I wanted to do, I guess, this troubleshooting spanning tree. Y'all let me know. All right, gonna check y'all out tomorrow. Yeah, let's just call it a night, man. I like to try to keep these streams under an hour. I want to make y'all like tired of shit like that, man. But anyways, for now, comment, like, subscribe to the network, bruh.